Hello, this is the second activity in the Forces, Matter, and Energy kit. It is the static electricity activity. So for this one, there's three parts. The first one has to do with a levitating ring. That one's really cool. I'd suggest you try it on your own and see if you can make it work. If you can, it's one that you can always do to show your kids. It's just a really cool example of static electricity. Whether you do that one or not really doesn't matter before you start digging into the second part of the activity, which is where we're going to start working. It's called balloons and cans. And for this activity, we need to assemble what we're calling Charge Detector. A really fancy device that we created that can detect a static charge. This is what it looks like. It just has a copper wire with a straw and a couple of aluminum foil leaves at the bottom. There's directions in the teacher's guide, but I'm going to go ahead and walk you through how to make one. First thing to do is take the lid that comes in the kit. Use a ballpoint pen or something to get a hole started in the middle. And once you get the hole started, you can use a scissors that's in the kit and poke a nice round hole. Once you do that, place the small straw so that it goes through the lid. Put that off to the side for now. And now we got to deal with the aluminum foil leaves. You need to cut these out of the roll of aluminum foil we provide for you. Here's the foil that I've been cutting some of them out. They look like little footballs, I guess, or little teardrops. And one of the hard things is you have to poke little holes in the end of it so that way they will stick to the or hang on the copper wire. So take the wire, make a little fishing hook like so, and go ahead and I have to do this one. Hang the aluminum foil leaves. There you go. So now I have two aluminum foil leaves hanging on the end of a hook. Make sure that they're free flowing so that they can move around. Keep the wire straight and run it through your straw. You can close the lid, and at this point we have the leaves at the bottom. And now I'll do a better job if I had a little more time, but once you get the bottom together, go ahead and make yourself a coil of the remaining copper wire at the top. So these are the charge detectors. There's 8 of them in the kit. You'll have to have them assembled before this activity. All right. So jumping into our activity with the charge detector, first thing you do, students are going to have their own balloon. The kit comes with a balloon inflator so you can keep the germs from all the balloons. First thing you do is you take the balloon, put it next to the foil leaf, the charge detector, and if you look at the foil leaves, nothing's really happening. At that point, you want to go ahead and take it, rub it on your shirt, rub it on something. And now you see, what do you notice at the bottom? You see the foil leaves moving a little bit. So now we have a charge. This thing has somehow received a charge, and that charge is being identified here in the charge detector. So, students will notice that when we charge a balloon, sometimes we notice the charge in our charge detector. The first part of the activity, I would ask students to take a balloon and rub it on different things around the room in terms of their shirt, their jeans, try different things, and see if they can see what combinations cause the aluminum foil leaves to move. Today's a pretty humid day here in Durham. It's warm and humid, which is not the best day for static electricity. Think about when you are walking in your house and you get a static shock. Usually it's in a cool day or a day that's very dry. Those are the days where it's going to work best, but it still will work. It's just going to be a little different. So after the students go around and explore charging a balloon and figuring out a charge detector, now we go ahead and we introduce three solids, three sticks that they can use. We've got plastic, wood, metal, and we also have three different cloths. We have cotton, I think that's cotton, yep, wool, and fleece. And their challenge is to figure out which combination creates the greatest charge. And also which combination just creates a charge in general. So, for example, students would have to make a chart and test all of these out. So, we'll try the metal with some fleece. What students can do then is, again, not touching the coil rod, but touching right next to it, and they'll notice not much is happening here. So they can pick something else. They'll have to try them all. If plastic and wool, the way to charge it is just to rub the two together, like you see here. Whoa, put it right next to the charge detector and you can see the foil. So now we know that for some reason these two objects created a static charge. So the biggest part of this activity is for students to explore and test different objects out. Several of these combinations will not produce a charge at all, and that's one of the things that we want students to notice. But some of them will make a tremendous charge that you'll be able to see, as we saw with the plastic and the wool. After they do that, share their examples, share their results with each other. The last part is to have students come up with what they think is the best combination to move an aluminum can. So you put an aluminum can on its side. Pick the two they think will work the best. And without touching the can, they should be able to get the can to move. Using only static electricity. And once again, what type of attraction or what type of charge do we notice? We notice that it's an attraction, so what does that tell us about the two different charges? Students should be able to apply the knowledge that they took from the magnetic activity and realize that if it's attracting, then obviously it has different charges. So this is an opportunity for students to explore static electricity, determining which things cause static electricity, and then identifying what type of charges are happening based on whether it's repelling or attracting.